Hello everyone and welcome to e-sipnayan. For this video, I will be discussing mean, variance, and standard deviation of sampling distribution and central limit theorem. Okay, so our objectives. First, we will be solving for the mean, variance, and standard deviation of sampling distribution. And also, we will enumerate the properties of central limit theorem. And then, we will be solving for the mean, variance, and standard deviation of sampling distribution. This time, we will be using the central limit theorem. Okay, so here are the formula for getting the mean, variance, and standard deviation of the sample mean. So the formula for the mean of the sample mean is equal to summation of sample mean times probability of the sample mean. And then the formula for the variance of the sample mean is equal to summation of sample mean squared times the probability of the sample mean minus mean of the sample mean squared. And then for the standard deviation, notice that this one is just the same with the formula for the variance. So therefore, to solve for the standard deviation of the sample mean, we can just get the square root of the variance. So this formula can be used if we have the sampling distribution. So let's have the first example. The table gives the monthly salaries in thousands of pesos of 5 officers in a government office. Suppose that random samples of size 2 are taken from this population of 5 officers. So here are the 5 officers and their corresponding salary. So this is in pesos. So we are to construct the sampling distribution of the sample means for number 1. So in constructing the sampling distribution of the sample means, first, we have to identify the number of samples. Since our population is 5 and we are to get 2 samples from it, so the number of samples is equal to 5, choose 2 is equal to 10 samples. And then we list down all these samples. So here are the samples listed. So 8, 12, 8, 16, and so on. Last is 20, 24. So it's better if you will be listing your samples, make it organized, or as much as possible have patterns in listing the samples. And then we compute for the sample mean. After listing, you compute for the sample mean by getting the average. So 8 plus 12 divided by 2 is 10. 8 plus 16 divided by 2 is 12, and so on. And then 20 plus 24 divided by 2 is 22. And then we compute for the probability of each sample mean. So we arrange it from lowest to highest value. And then we compute for the probability of each. So 10, the sample mean 10 only appeared once. Okay, so yung frequency lang niya ay 1. So therefore, ang probability ng 10 ay 1 over 10. Okay, so 10 kasi yun yung total number of samples. And then 12, isang beses lang din. So the probability is 1 over 10. 14, twice na lumabas sa sample mean. So therefore, the probability is 2 over 10. Simplify, that's 1 over 5. Same with 16, 18. Probability is 1 over 5. And then 20 and 22 are both 1 over 10. So this is the sampling distribution of the sample means of the given situation. And then for number 2, we are to construct the histogram of the sampling distribution. So the histogram is simply the bar graph of the distribution. So we create a histogram or the bar graph. So at the x-axis are the sample means, and then in the y-axis are the probabilities. So here we have 10. First, ascending, again, yung paglalagay ng values ng sample means and the probability. So 10 here, the probability is 1 over 10. 12 is also 1 over 10. 14 is 1 over 5. 16 is 1 over 5. 18 is 1 over 5. 20 is 1 over 10, and 22 is 1 over 10. So this is the histogram of the distribution, of the sampling distribution. Next, we solve for the mean, variance, and standard deviation. So in solving for the mean, we will be using the formula summation of sample mean times probability of the sample mean. So to do this, or to use this formula, we will multiply the sample mean and its corresponding probability, and then we get the sum of the product. So that will be 10 times 1 over 10 plus 12 times 1 over 10 plus 14 times 1 over 5 plus 16 times 1 over 5 plus 18 times 1 over 5 plus 20 times 1 over 10 plus 22 times 1 over 10. And then the answer is 16. So the mean of the sample mean is equal to 16. Next, variance. So to solve for the variance, we get the sum of sample mean squared times probability of the sample mean and then we subtract mean squared. Sample mean squared to it. So that will be 10 squared plus 10 squared times 1 over 10 plus 12 squared times 1 over 10 plus 14 squared times 1 over 5 plus 16 squared times 1 over 5 plus 18 squared times 1 over 5 plus 20 squared times 1 over 10 plus 22 squared times 1 over 10. And then we subtract 16 squared to the sum of these products. So 16 squared, where do we get 16? Dun siya sa na-solve natin kanina. Okay, so here, the mean of the sample mean. Okay, so minus 16 squared, and the answer is, for the variance, that will be 12. So the variance of the sample means is 12. Next, for the standard deviation, so since we already have the variance, to solve for the standard deviation, we can just get the square root of the variance. So that will be square root of 12, and that is approximately equal to 3.46. So the standard deviation of the sample means is equal to 3.46. Okay, next example. So given the situation, so it's just the same. We're still using the same population, but this time, the random samples of size 4 are taken from this population. So 4 samples ang ating kukunin, or the sample size n is equal to 4. Okay, so again, for number 1, we construct the sampling distribution of the sample means. So first, we identify the number of samples. Since 4 na ang ating sample size and our population, we still have 5 elements in the population here. So 5 choose 4, that will be 5 samples. And then we list down our 5 samples. And then we get the sample means, or the average of each sample. So that's 8 plus 12 plus 16 plus 20 divided by 4. The answer is 14. 8 plus 12 plus 16 plus 24 divided by 4, that will be 15, and so on. And then we construct the sampling distribution of the sample means, again listing all the sample means from lowest to highest and getting the probability of each. So si 14, isang beses lang siyang lumabas sa sample mean. So the probability of getting 14 as the sample means is 1 over 5. So 5 is the denominator because that is the total number of samples. And then 15, 1 over 5, same with 16, 17, and 18. The probabilities are 1 over 5. And then next, number 2, construct the histogram of the sampling distribution. So again, using our answer in number 1, we can construct the histogram. Y-axis are for the probabilities. So we arrange the probabilities highest to lowest. So in this case, 1 over 5 lang lahat ng kanilang probability. And then, lowest to highest then ang sample means. So 14, 15, 16, 17, 18, and all their probabilities are 1 over 5. So this is the histogram of the sampling distribution. Okay, next. Solve for the mean, variance, and standard deviation. So to solve for the mean, again, we're using the formula sample means times probability of the sample mean. So we multiply the sample mean and its corresponding probability, and then we add their product. So that's 14 times 1 over 5, 15 times 1 over 5, 16 times 1 over 5, 17 times 1 over 5, and 18 times 1 over 5. And the answer here is also 16. So the mean of the sample mean is equal to 16. Next is the variance. So formula for variance is summation of sample mean squared times probability of the sample mean minus mean of the sample mean squared. So we add the products of sample mean squared times probability of the sample mean. So that is 14 squared times 1 over 5 plus 15 squared times 1 over 5 plus 16 squared times 1 over 5 plus 17 squared times 1 over 5 plus 18 squared times 1 over 5. And then, once we get the sum of these products, we subtract mean squared, or mean of the sample mean squared. So that will be minus 16 squared. So we got 16 a while ago. And this is 2. So the variance of the sample mean is equal to 2. Next is the standard deviation. So that will be, we already have the variance. So to solve for the standard deviation, we just get the square root of the variance. So that will be square root of 2. And this is approximately equal to 1.41. So the standard deviation of the sample mean is approximately equal to 1.41. Okay. Next, we will be identifying the properties of the central limit theorem, and we will be solving for the mean variance and standard deviation using the central limit theorem. So first, let's talk about the first property. The mean of the sample means is the same as the population mean. Hence, the following formula, mean of the sample mean is equal to the population mean. So look at in the examples a while ago, iba yung sample size natin. Okay? So, yung isa size 2, yung isa size 4. But notice that we will arrive at the same mean. And also, if we get the population mean, so our mean of the sample mean is 16. So, if we get the population mean, so ang population mean natin is the average of the population. So, ang population natin ay yung lahat ng salaries. So, that will be 8 plus 12 plus 16 plus 20 plus 24 divided by 5. Notice that the answer here is also 16. So hence, it is always like this for any situation. The mean of the sample mean is equal to the population mean. So this is the first property of central limit theorem. Next, the central limit theorem states that if you have a population and you take sufficiently large random samples from the population, then the distribution of the sample means will be approximately normally distributed. So in this property, ibig sabihin nito, if we get large sample from the population, ang tendency magiging normally distributed na yung ating distribution. So look at this, look at the standard deviation that we got from the first example and in the second example. So, dun sa first example natin, wherein we only get 2 samples from the population, we have a bigger standard deviation. And then, sa pangalawang example, where our sample size is bigger compared to the first one, our standard deviation is smaller. And it is always like that. If the sample size is large, or if the sample size is bigger, the tendency is the standard deviation becomes smaller. So, kung lumiliit yung ating standard deviation, recall that standard deviation is the average distance of all the data to the mean. So, since lumiliit sa standard deviation, mas nagiging compress yung data. Mas lumalapit lahat kay mean. So, ang tendency, mas nagiging normally distributed siya. Okay? So, that is property number 2. Next is number 3. The standard deviation of the sample mean is equal to the standard deviation of the population divided by the square root of the sample size. Hence, the following formula. So this formula can be used in solving for the standard deviation of the sample mean. So standard deviation of the sample mean is equal to the standard deviation of the population over square root of n, or square root of the sample size. So this formula is useful if we're solving for the standard deviation given the standard deviation or the variance of the population. Let's have an example. Example number 1. A school has 900 junior high school students with average height of 68, with a standard deviation of 6 inches. If you randomly select 50 students, what will be the value of the mean, variance, and standard deviation of the distribution of all sample means that can be derived from the samples? So, instead of constructing the sampling distribution of this situation, pwede rin na gamitin natin yung mga property na na-discuss kanina under central limit theorem. So, first, let's solve for the mean of the sample means. So, in central limit theorem, it states that the mean of the sample mean is equal to the population mean. And the population mean is given in this problem. So, it was stated na itong 900 junior high school students, ang average height daw nila ay 68. Therefore, this 68 is the average of all the students. or of the whole population. So we can say that this is the population mean. So therefore, if this is the population mean, we can also say that this is the mean of the sample means. So the mean of the sample mean is equal to 68. Okay. Next, we can solve for the variance and the standard deviation. So we have the formula for the standard deviation. We can solve for the standard deviation first, and take note that the standard deviation is the square root of the variance. So we can also say that the variance is the square of the standard deviation. Okay, so we can solve for the standard deviation first, and then square natin yung standard deviation to get the variance. So standard deviation of the sample mean, we can use the formula here sa property 3, which is standard deviation of the population over square root of n. So we can use this formula because in this problem, the standard deviation of the population is given, which is 6 inches. So this is the standard deviation of all the 900 students in the junior high school. So that is this is also the population, yung 900 junior high school student. So 6 inches is the standard deviation. So this will be 6 over square root of the sample size. So the sample size here is 50 because ito yung number ng student that will be selected randomly to the population. So 50. So square root of 50. And 6 over square root of 50, this is approximately equal to 0.85. So the standard deviation of the sample mean is 0.85. And then we solve for the variance. The variance is simply the square of the standard deviation. So we just get the square of 0.85. And this is approximately equal to 0.72. So the variance of the sampling distribution is approximately 0.82. So the mean again of the sampling distribution is 68, and then the standard deviation is 0.85, and then this should be 0.72 rather. Again, square of 0.85 is 0.72. So this is 0.70. Okay. So that is the mean, variance, and standard deviation of the sample means. Okay, next, number 2. Random samples with size 4 are drawn from the population containing the values 14, 19, 26, 31, 48, and 53. Find the mean and the standard deviation of the sample means if the standard deviation of the population is 14.3. Okay, so again, we are to solve for the mean and standard deviation. So to solve for the mean of the sample means, again, we will be using the property of the central limit theorem wherein the mean of the sample mean is equal to the population mean. So the population mean is not stated in the problem. However, the values of the population are given. So we can just, instead of doing the sampling distribution, we can just get the average of the population or the mean of the population. So that will be 14 plus 26 plus 31 plus 48 plus 53 divided by the number of elements in the population. So that's 1, 2, 3, 4, 5, 6. So divided by 6. And this is approximately equal to 31.83. So the mean of the sample mean is approximately equal to 31.83. Next, we solve for the standard deviation of the sample means. So to solve for the standard deviation of the sample means, we can use this formula because the standard deviation of the population is given. So our formula is standard deviation of the population over square root of n. So standard deviation of the population is 14.3, over square root of the sample. So a random samples with size 4. So this is the sample size 4. So 14.3 divided by square root of 4, that is equal to 7.15. So this is the standard deviation of the sample means. So we are not asked to get the variance, but if we will be getting the variance, we just have to get the square of 7.15. Okay, so this is the mean of the sample means 31.83, and the standard deviation of the sample means is 7.50. And that's it for our lesson for today. Do not forget to like and subscribe to e-sipnayan.